For today's episode, we are going to degree the cam, make sure the cam is proper per the specs on the spec sheet, and then we will hopefully get a little bit more done. Hopefully I can get the bottom end finished up. I'd like to make sure this is a ready to go short block is what it would be. I'm going to get the oil pan, things like that on, and yeah, let's begin. Let's get this thing going. Now the oil I put in here, yeah, it's new, but it was the cheap stuff, and I don't want to deal with trying to salvage it. But these are the lifters. I soaked them in oil overnight. Okay, when I put this camshaft in, the only thing I put the assembly lube on was the cam bearing areas. The reason for that is it's a roller cam. It's unnecessary to coat the entire thing like that. Now I have a homemade concoction of an assembly lube. It's a combination of zinc additive, like the Lucas zinc additive stuff, Lucas oil stabilizer, and automatic transmission fluid because of the detergent that's in it. That's the only reason I put that in there. Now I'm just going to take and I'm going to pour it down the lifter holes, lifter bores, trying to coat a little bit of everything on there, and yeah. Due for a new degree wheel pretty soon. This thing's pretty well worn out. Should probably get a decent one for once. Alright, so what we gotta do, I gotta get a plate on here so that we can have the piston stop at top dead center, and I can rotate it back and forth. I'm gonna snug this up a little more so I can make sure I can crank the thing around. Wow. Took me a little bit to find these head bolts. They were sitting on top of the cylinder heads. I actually put them in a place that made sense. Why would I do that? Anyway, so I got one of the head bolts. I have my balancer puller. If you've seen previous videos, you've seen me use this. This is a custom-made giant chunk of metal that I turned into a balancer puller. Anyway, so what I'm going to do here is I'm going to use this hole because it's large enough to fit the head bolt down in. And I'm going to put this plate right here, because this side is nice and flat. This side's got a little bit of a bulge. But all I'm doing is I'm going to bolt this down because being this piston has a thing above it, it's going to actually stop before it gets to top dead center. And my goal here is to use this as a piston stop to find top dead center. So what I'm going to do is I'm going to turn it until it stops, go all the way the other way until it stops, and remember each degree that it lands on. And then I got to find the center line of that degree, and then I have to put the motor in that position, and then loosen this up, turn it, check it again. It's going to be a couple of times that I'm going to do it until I get it just right. So. I'm just trying to bend this so I can get a more accurate reading. This is just a piece of welding filler rod for a TIG welder, and I just use it for my indicator of the degree. I'm going to guesstimate 15 is going to be about right for that piston. Hopefully I get 15 on the other side and I don't have to do anything, but I know how that goes. Never ends up the way I want it to be. So what I'm trying to do is I'm trying to make it so that each side that I go to ends up on the same number, just opposite of the top dead center. Once I get that, then I know I have top dead center on the dial. There we go. 22.5. Let's check the other side. 22.5. Alright, we're set. We have top dead center. Now I gotta pull this guy back off. There, that is actual top dead center. Now, we need to get our dial indicator down on these lifters. The only downside is I don't have a proper tooling or jig system to create a way to center up on that lifter really well. I probably should create something, because I do this a lot where I have the deck of the block wide open like this. I mean, if you had the cylinder heads on, you could use the part of the rocker the push rod goes against, except for that the lifter collapses. That'd be only on a solid lifter vehicle. This is hydraulic, so you can't do that either. So what I'm going to do is I'm going to find a socket that fits down in the hole for this guide plate. That fits reasonable, not too tight, not too loose. Then I'm going to put a extension on it and put the dial indicator down into it. Okay, so here's my setup. It happens to be a 9mm Craftsman socket. For some reason, the outside diameter just matches what I need. It's just slightly loose, yet inside the hole for the plastic lifter guide. That plastic lifter guide is what I'm basing it off to keep it centered. The lifter itself has a spring in it that's higher pressure than the spring of the dial indicator, so I know that the lifter isn't going to collapse, even though it doesn't have technically oil pressure or anything in it. I know the lifter's not going to collapse under the load, the light load this is going to get. I put a 3/8 to quarter adapter on the end of the socket, and the reason I chose that was because, first off, my extensions that I have, the short ones, they don't have, I have all little wobble ones for my 1/4 inch, for the really the stubby little guy. But you want to use something somewhat short, closer to this the better. And then this thing in the center of it, it has a drill bit kind of a mark, so it's like this. So when I put that dial indicator in there, it's going to sit in the middle of that valley. It's crude, but it works. We will start with the intake. I will grab the center line specs on there, and then we'll figure it out. I'm sure you've noticed this giant chunk of iron here. That's for an obvious reason, if you think about it. It's the fact that I have a aluminum block. Since I have an aluminum block, this magnet of the dial indicator is not going to go on there very easily. So I have to come up with a way to hold it down that can keep everything stable and in place. Cam specs go to a at 50, so I got to turn it until I get to the intake, the beginning of the intake, and when this dial says 50, that's when I have to measure where it is on the degree wheel. Oh, I need to invest in a camera. I just missed a whole bunch of things, I bet. Hopefully not. Alright, I just got done getting the intake properly set. It took a little bit of finesse, but I got it. I was an idiot. I didn't pay close enough attention to the cam card. So, they say intake minus 13.5 before top dead center. Why they wouldn't just say 13.5 after top dead center is beyond me. Okay, so we're going to do the exhaust side now. Just to be sure, we're going to hit the exhaust one. Even though the intake is within spec, now it's basically verifying that and that the cam is correctly ground. So I am literally off on the intake and the exhaust almost a degree, about a half a degree. And there's no way I can make up for that. It's impossible for me to get an extra half a degree out of a non-adjustable timing setup. There is a company, I think it's Comp, they make a degreeable cam deal. It's got like a little offset keyway thing, and you put an Allen in there, you loosen the bolts, put an Allen in there, and then you can turn this cam thing, and it'll just, you can really fine tune a cam if you want. There's no way I'm going to get this thing that close. But within a half a degree is pretty dang good. So let's check, just for good measure, let's check after top dead center on the exhaust as well. Oh, there we go. Really close now. There it is. All right. So I should be at 2.5 after top dead center. I'm sure I'll be half a degree off. I am half a degree off exactly, so I am at 3 degrees, which coincides with the rest of it. So this cam is ground exactly how it's supposed to be ground, and I have it in the correct position. Now I get to assemble everything, take all my crap off of here, and then continue the assembly process. Alright, we got it all degreed. Now it's time for a little oil pump action here. We have a high volume oil pump because of the slightly extra clearance that I have in the bearings. I don't have much extra clearance, but there's a little bit. And I want to make sure that this thing does not lack oil pressure up top, since he revs this thing out quite a bit. Now this is the Mellings upgrade pump. It is a 10296. This is a really good general purpose performance pump for these cars. It can drive some pretty good stuff. I have one of these in a car that's making over 900 wheel horse, and it does the job. In fact, it does the job so well, he did some baffling down below, and it's causing a sucking it dry scenario under heavy load, probably because of sloshing to the back and everything else. So we're going to be addressing that soon. This is my favorite RTV. It's called Bright Stuff. It's by Permatex. It's extremely thick, and it doesn't get affected so badly by oils and stuff. If you have a little bit of oil in the way that you didn't see or something, you're not going to all of a sudden have a leak. It tends to still seal somehow. Works really well. I'm going to put just a little dabble right where this bottom of the gasket meets the timing cover, in the corner of the oil pan area, on each side of the gasket. Just a little drop is all it takes. And then once I bolt it on, I wipe it off from underneath the oil pan area here. Now, I gotta replace the seal here, but I'm about to put this rear cover on. This rear cover, you need to make sure before you put this rear cover on that you install this plug. This is the plug that sits right here, and its purpose, well, down and in the block, but its purpose is to make sure that the oil goes through the oil filter rather than just pressurizing the system. It's the deflector for the oil. Oh, I made a mistake. I'm supposed to do this thing and the oil pickup tube before I put the timing cover on. It's not the worst thing in the world because none of the RTB's dried or anything. All I gotta do is pull it back a little bit. But this bolt is very hard to get at unless I do this stuff first. So I'll go ahead and get this guy bolted on, and then I'll address that. Okay, so here's an interesting thing. These holes are not big enough, the centering holes, because the original The original has smaller studs here. So I'm going to get those guys drilled out. Okay, this is a must-have. It's a ICT product. It's a billet pickup girdle. So it's a thing that basically supports this oil pickup. And here, let's open it up quick. But basically, one of the problems these vehicles have, specifically for things like the Corvettes, is this pickup tube. Because it's only bolted on this one spot. You know, if they had another bolt right here, I suppose it'd probably be a lot less likely to have a problem. But being it's only right here, this pickup tube has a tendency of flexing like that. You know, because of weight pulling it down or whatever, I don't know. But then the O-ring will suck air in. It'll cavitate the oil. Next thing you know, you're putting bearings in your motor. If you put this piece on, it supports it on more than just a single bolt hole. It actually supports on the bolt hole behind this tube as well, and then brackets it and holds it down. So this is a safety measure, safety precaution that you can take. I think it was like 26 or 28 or maybe 30 bucks, I don't know. Of course, I have to mark it up a little bit when I sell it, but I don't go much, maybe 32 bucks. Just enough so that I can keep the doors open. So, comes with a couple bolts, and it comes with this little billet piece of aluminum that you put on there like a so, or yeah, like a so. That doesn't seem right. Seems like it'll cause an issue, but either way, I'll get it on there. But I gotta pull this back down, or back out, because I was a doughhead and put it on too early. Obviously, there's no way to actually torque this down properly. I mean, maybe a crow foot, you can get close, but I'm just going to feel it. This thing is ready for an oil pan now. So I'm going to get the oil pan gasket and the oil pan, and we're going to put that on. Given that dent right there, I'm going to put a little RTV along this area of this gasket, just to be sure I don't end up with a problem later. That would suck to have a leak right there in the back. I'd probably think it was a rear main or who knows what. Now, a Corvette, that is not an easy thing to fix. So I have this VR1 racing oil. It is a 20W50, says high zinc on it. And when it comes to the first startup on engine oils, things of that nature, I tend to just kind of mix and match mutt the oil. Call it just a mix mutt. What I'll do is typically I'll use one of these, assuming I have them here. Usually I do. I use it because of the high zinc and the fact that it's a little bit thicker. The first startup, I want a thicker oil than what's going to be running the car normally. Now if it's a full-on race engine, I just straight up do a decent quality oil such as this, as long as it's got the zinc. Now the reason I say the zinc is a lubricating metallic kind of a thing. And it's not needed as much in modern motors, and in fact the EPA is against it for street engines, and the reason being is it's considered a pollutant. But for break-in oil, they're not gonna. I highly doubt they'll have a tizzy over a break-in. Doesn't really matter. I know none of you are gonna care about EPA crap. So I do that first. This particular motor with the 1.5 thou main and 1.5 thou rod bearing clearance. The 1.5 thou rod bearing clearance is a little bit more clearance than the standard, the stock clearance. So with this being a 1.5 thou motor, I'm going to do one of those quarts of the 2050, and then I'll be doing some just 1030 stuff. maybe 1030 or even 1540 for the break-in. And the reason I run it thick for break-in is this ring break-in part of it, and that's part of the reason for the zinc. These cylinder walls are really aggressive on the skirts. So by having the zinc in there, you are going to protect the skirts during the break-in period, at least until these cylinder walls have glazed over enough because of the rings wearing into them. And once your break-in is done, then who cares about the zinc at that point? The motors are full roller motors, so it really doesn't matter. Zinc was used heavily in old motors, specifically for flat tappet lifters. And the flat tappet lifters, the zinc helps keep the galling down and the damage down on those, but it's not needed anymore, like I said. So I just use it to try and prolong the life of the skirt or keep it as little damage as possible while it's during its break-in period. So I accomplished a lot today in a short period of time. It actually did not take me very long at all to do this part of it, and I hope you enjoy this video as much as I enjoyed making it. I love doing these motors. I don't know why, I just enjoy assembling engines. There's just something about it for me that I really enjoy. And if you decide to do it, take on the project yourself for personal, you know, there's a lot more to assembling a motor than what I've gone over on these videos. I mean, I still got the cylinder head half to go to yet, and you'll see that here in the next following video or 2 or 3 or however long it takes me. But there's a lot more to these than meets the eye. There's a lot of little tricks and tips and things that just go into so much detail, it's insane. But I feel I did a good job of covering most of the basics. And the plasti gauge thing that I did on a previous video, you'll notice that I did plasti gauge. It wasn't just because that's how I go about it. It's a security thing for me. I always have them measured at the machine shop. I tell them what I'm looking for, and they go about measuring it, and they tell me, you know, this is within this spec, and hopefully it's going to work out. Depends on how many bearings are correct. You know, the bearing, they can't predict the bearing size unless I sent them bearings with them and they measured the bearings. They're not going to know that. So you could use a bore gauge on the bearings, and I would like to in the future. I just got to invest in the tool. But the plasti gauge is a guaranteed, if you use it properly, guaranteed way to know that you have adequate bearing clearance. And it's just a good security measure. And plus, on top of that, for the people who, like myself, don't have the equipment to measure it, it's a good way to measure on a budget. You know what I mean? So you don't have to spend a fortune to have the tools to build these. The torque wrench is a little spendy. That's a definite necessity. But these are fun to do for me. If you like tinkering with nuts, bolts, and doing things like that, these are a lot of fun. So if you like this video, smash that like button. Be sure to subscribe, and don't forget about hitting that notification bell if you like seeing any videos that I bring on. It'll be every Friday. I will be bringing a video, and then the occasional bonus video. So yeah, thanks for watching, and I hope you enjoyed, again, the video as much as I enjoyed making the video.